So thanks for the kind introduction. In the run-up to this keynote, I thought about like how am I going to make this successful? And I've made two strategic decisions. Number one, who do you think has the most keynotes in the drone industry? Right, so you need to walk a lot on stage. Because if you do that, you get invited to all the keynotes, like Michael Chasen. So I'm going to keep doing that. The other thing I did is I have rehearsed exactly 0 times. Because that's when I'm natural, and that's when I'm at the best of my game. Auterion is a company that has US business, but we come from Switzerland, and you see the drone in the top left. And when you see that video, you know why you're in this industry, because it's just so intuitive, it's native, it's in every living being. Drones are just so cool. Let's do that again. You can't unsee this. And it's crazy. It's crazy. I mean, now I can go off stage and you take something home and Mike can share the YouTube link to the video and we've already won, but we have more good stuff. Before that, I need to take you on a small history tour because I can claim a few things that few people in this room can claim. I'm in this industry for 11 years. That's like pretty much since I was 3, if you look at me. And it started really like all the people that started in this industry over a decade ago. You don't do it for a reason. You do it because it's cool, and you think it's cool, and everybody else think you're like a weirdo. So I wanted to do computer vision as my master's. And I wanted to do computer vision on something, not something that drives, but maybe something that flies. And that was the whole point. Do obstacle avoidance, fly indoors, and all the things that are more or less commonplace today. And 3 weeks into the project, they realized, like, oh, wait, to do computer vision on something that flies, you maybe need an autopilot. But back then, there were no autopilots. You couldn't buy this. This box that we have today, it did not exist. And the MEMS gyroscopes that are commonplace today and will be replaced by laser gyroscopes soon, they were barely existing either. Because phones hadn't been really discovered as a gaming device, so phones didn't have cheap angular rate sensors, so there were no cheap angular rate sensors. And so around 2008, which is around the same time where the smartphone really started to exist, we started to get these sensors. And I forgot to walk, sorry. So around that time, imagine we're here 2008, and now we're going through this, right? We're going to go a bit back and forth. Now, we built one of the first autopilots with MEMS sensors, 2008. And 2009, I had by then put a small student team, 14 people around me. We won the European micro air vehicle competition. Now you might ask yourself, what is a micro air vehicle? Well, that was a drone back then because 2009, a drone was a predator. That was a drone. 2009, this stuff with multiple propellers was a micro air vehicle because it was a purely academic thing. And we kept doing that, and the software architecture actually looks the same like it looks today. And I made one good strategic call. I decided, well, let's not try to found a company in this early stage. I'm going to stay in academia. I'm going to do my PhD. But because I'm not leveraging anything of the IP that we had built as a student team, let's put it out there. Let's make it available as open source. And as one of the younger open source developers, I decided I don't actually want to prescribe how people are using it, what they do with it, what they have to do. I'll just make it permissively licensed, so under the BSD license. And that was a very strategic decision because I thought, well, probably it's completely useless because we're just a bunch of students. But if it is useful, then it has the best chance to grow into something. And so the first project that was actually adopted was Mavlink into ground control. So that's something super boring, like regulation. Sorry if any regulators are here. It's a communication protocol, and it allows you to talk to the ground station in a defined way. That got picked up first. And then 2010, we started to get adoption for that in a wide fashion, multiple autopilot projects. But the flight control software on the flight controller was really crappy. So we rewrote it a couple times. It was the Pixhawk software, so shorthand PX. And the reason it's called PX4 is just that that's version 4. And that kind of stuck because it actually did work. And then over the years, well, what's the next problem you need to solve when you try to do software to power a widget? Well, you need a widget. And that's Pixhawk, named after the student team from 2008. That was the autopilot where I and a co-conspirator created the whole hardware design. And then 3DR picked that up as a kit to sell. We made that available as open hardware. And that's where it really started to get traction. And there was a big partnership with other open source autopilot communities. And then eventually that led part to be part of the Linux Foundation. That's when you know you've made it, now you're corporate. But it was not enough for one thing, and the problem is with open source, it's hard to use. It's inherently generally hard to use. You need an enterprise version or somebody that's packaging it up for you. And I was sitting there for 1 or 2 years, 2016, 2017, and thinking like, oh, this is not going well for PX4. People complain, it doesn't work, it's too hard, I don't understand it. And nobody did it. So I decided, well, around 2017, it's time. There needs to be an enterprise player, an enterprise solution that takes all this great work and makes it accessible for the industry. And that is exactly what Aterian is doing in a nutshell. Now, going back, this is what we did 2008. That's an open loop takeoff, so controlled crash. And then you see that's vision-based navigation, right? What do you do first? Well, you instrument the environment. So the drone is not actually following the pattern. The pattern is there, so it knows where it is because it knows where each of these markers are. And you can see it's kind of jerky, and it's not super fast, and it's not super pretty. But that thing flew completely autonomously with vision-based navigation 2010. With a bunch of students who didn't know what they're doing, but were dangerous enough because they had the internet. And so now I'm feeling old. And over the years, we started with really 2 contributors, but now it's hundreds. It's hundreds. This is just an excerpt of the contributors we have today. And you can see a lot of random profile pictures on GitHub. I typically find that the hobbyists, they put their picture on there, and then anybody working for a company doesn't care or doesn't want to. And so no profile picture on GitHub is a good indicator that it's a professional. And by the way, there's a word that was formed in our community. It's called I know you from GitHub. Because you meet that profile picture for the first time in real life. And I actually got that reaction today again. And now, well, that's so far cute and nice and great. But here's the problem. As you start to have higher level functionality, computer vision, obstacle avoidance, you start to have more and more stuff on your drone. Each of the things is just a small slice, but if you stack up slices, you're forming an exponential curve. And that is the core reason why it will be really hard for any proprietary entity to keep pace with this development. You need to be having an enormous market share, and there are certain companies in the drone industry that do have an enormous market share, to sustain that. And then you can do it. I'm not discounting that. But if you don't have that market share, if you just have a single-digit percentage market share, you're not going to survive. So this is the only way. And it's a bit like in the smartphone space, right? You have the proprietary integrated solution, and you have the more open solution called Android, and Android is a stack of a ton of open source software. And to do that, you also need increased headcount, as we call it in business. You can measure headcount through the activity, which is the commits, and you can see that that's an exponential curve too. That's the only way to keep up. And it actually shows that our community is healthy, because if it wouldn't grow that way, we would have a problem. The other thing, we had the first developer summit this year in Zurich, and we thought like 30 people, you cannot really see it in a picture. 200 people showed up. And because we're a bit unprofessional, we organized it with like 4 weeks notice. 200 people on 4 weeks notice. That shows real demand, and that's real critical mass. And so I think that's a real step change in this industry. And we do cool stuff. We do, for example, tail sitter VTOLs. This video is like 4 or 5 years old, done by one of my students, who is now the lead for VTOL flight control in PX4. That video was before you saw any other VTOL. You just didn't know it existed. That was before Amazon, Wingtra, anybody else. 4 or 5 years ago. I would need to look it up exactly. But you can see it holds position. That was one of the first flights. You also see he's a bit unsure, but it worked. And you can now buy essentially the code base that's driven that video, both as toys as well as $30,000 commercial products. And you know, when you build drones, at some point you're thinking about, okay, I'm building a flight controller. Now, I just hope that everybody understands that that flight controller, the small thing for hobbyists, is not intended to fly people. Because who would do that? That would be completely crazy. And I'm not okay with that, for the record. It's crazy dangerous. We didn't design it for it. But it's working so well that people trust it. And I mean, who would put jet engines on their back? I mean, that's totally crazy too. So this is a jet man who is flying around with jet engine on his back for probably the past 10 years. Crazy guy from Switzerland, you see the analogy. And that's quite successful. And that's not a puppet. That's him balancing, held by the trust of 4 jet engines. And if you ever try this, you know it's impossible. You see the form of the wing? That's PX4. That's PX4 right there stabilizing a human. And I think it's insane, and it's cool, and I absolutely do not recommend to do that. But as you clock up flight hours, as you have breath, as Linus Torvald says, given enough eyes, all bugs are shallow, you start to get the results that are really incredible. And so what you will start to see probably Jetman doing next, once he's through with his trial period, is go out and fly VTOL so he doesn't have to jump out of a helicopter anymore to take off. Awesome. Don't do it at home. And now you might wonder, okay, they've brought this student turned academic, turned open source developer, turned startup founder. Auterion has now 50 people. We're probably the largest avionics company in our size category by now. Yeah, but what do you do with this stuff? And then you start looking. You start looking and you realize, well, there's this product that's in the market for some time. And then there's that product, completely different looking, that's also running PX4. And then there's this mass market product that's also running PX4. And then there's this monster that's not an RC Cessna there, right? Look at the people on the left. That's also running PX4. And I don't know what Amazon Primary is doing these days, but I can say that I had some very deep discussion back in the day with them. So it's probably a question of definition what that thing is running now. So it's everywhere. It's everywhere. People just don't know. But it's driving common standards already. Again, now that VTOL is a bit boring after you've seen Jetman, I apologize. But that's also working. That's a very powerful survey platform. And this commercial drone. So look left and right, and you'll find that everywhere. But as we all know, it's actually not all rosy in our industry. I could have filled multiple slides with this. I just picked the biggest pivots. And I also know I've set myself up for disaster. If anything goes wrong with Jetman or with Auterion, people are going to pull the recording of this. And that's perfectly fine because you need to take risks. But you see, it hasn't all worked out in this industry, but I think that's a good thing because you need to take risk and fail. And I like to explain things in analogies. And so I looked at smartphones and I looked at computers, and it's too similar. It's like confusing. So let's go back 100 years. What is this? So the automotive nerds know it's a Ford Model T. Now what's special about a Ford Model T? It's not the brand, doesn't matter. It's two key things, two key ingredients that show you when an industry is mature. Number one, it has product market fit. If you look at this car, there's nothing about it that you do not have in a modern car as well. It's different. Different wheels, different steering wheel, different suspension, but it has a gasoline engine, well, that had product market fit. It has a steering column. It's all the same parts. That thing is like steady state. That's a car. And the second thing is it's mass manufactured. I'm not sure if Ford was the only or first or whatever person, but that's largely attributed to the success of Ford, and that's what matters, right? Product market fit, mass manufacturing. And it wasn't the first car, it wasn't the last car, but it came around a time where you see a steep decline in the number of manufacturers because up until to that point, people had been manufacturing cars, doing everything, one man, one car, more or less, in a barn, and there were over 5,000 car manufacturers in America. 5,000, that's insane. Now, of course, that didn't work. And so that's what's exactly happening in the drone industry right now. This sort of one man, one woman, one drone manufacturing, all this integration, that doesn't work. We need to specialize. And specialization requires that you can mix and match. How do you mix and match? You mix and match through standards. And it's incredible, but back in the day, you didn't have standardized bolts. They were all bespoke. It took 10 more years until standardization in the whole mechanical industry was a thing. And you can see that with the incorporation dates of two of the largest standardization entities in the world. Now, standardization in software is a lot more complex than standardizing a bolt. And so we're kind of skipping forward. So instead of standardizing on a spec, we're standardizing on, well, let's all use the same code. And that's why open source is the agile approach to standardization. That's really the one takeaway message from this keynote. And that's going to be really important. And you can see it in every software-driven industry. And we see real traction. And this is not a commercial keynote in any way, but Auterion naturally is involved in this. So the Pentagon has adopted open source software for their short-range reconnaissance drone program. It's very real. It's a requirement. Q ground control is a government requirement. And then GE Aviation, big corporate, chose to work with Auterion to build a high-end autopilot based on open source software. So the US government and probably the most well-known US corporate move in the same year. That should tell us something. And that's why I think, and that's the title of my that's the title of my talk, and what I want to conclude with, open source is really enabling the next level of scale in the drone industry. It's what will us all allow to collaborate better, to have less redundancy, and with that, create an open ecosystem that allows smaller players to break the monopoly of vertical integration. Thank you.